Okay, so today we're talking about section 3-8. And in 3-8 we're dealing with slopes of parallel and perpendicular lines. Now, first off, before we talk about the slopes of these things, please remind me, what are parallel lines?
Lines that never intersect.
Two lines that are in the same plane and never intersect, absolutely. And then what about perpendicular lines? Lines that intersect and form a 90-degree angle, absolutely. Okay, so we needed to know those first. Now we know, or we're going to say today, that if two non-vertical lines are parallel, then their slopes are equal. In order for two lines to be in the same plane and never intersect, they have to have the exact same slope. Okay, then we also have that if the slopes of two distinct non-vertical lines are equal, then the lines are parallel. It's kind of the converse of the previous statement. And then lastly, any two vertical lines or horizontal lines are parallel. Because the first two statements we're dealing with non-vertical lines, and so we have to have a statement for vertical lines. Okay, well, why do you suppose they talk about non-vertical lines and vertical lines separately here? Well, if you remember back from Algebra 1, the slope of a line, let me draw us a line here. The slope of a line is measured by its rise over its run. Okay, we call this the rise. We call this the run. Now, one thing that I try to make sure all of my students know when I teach slope for the first time, for that matter, when I teach slope the third time in Algebra 2, I don't teach rise over run. You guys might remember it that way. But slope, first off, I guess we need to remind ourselves that slope is given by the variable m. Okay? It's because of some Latin word for change in height. But anyways, that's beside the point. M is for slope. And m is not rise over run. I say it's wise over run. Okay? Why do I say wise over run? Yes, it rhymes with rise, but also because it'll help you remember which one is the rise, which one is the run. Okay? Y coordinates are the rise. Therefore, you're counting up and down first. Okay? Left and right, that's your run, so that's the x. It's wise over run, and yes, you could write rise over run if you want. But please remember, it's wise over run. Wise over run. So if that's how we're going through and counting slope and calculating slope, then what happens if we have a line that runs vertical?
Isn't it undefined?
It will be undefined. Why is it undefined?
There's no rise and there's no...
Ooh, there is rise.
There's no run though.
There's no run. That's exactly it. You could count rise between any 2 points you wanted to. So right there, if I grab those 2 points, I could say that my rise is 1, 2, 3, 4, 5. I have a rise of 5. But my run, exactly, my run is 0. And we can never, ever divide by 0. Weird things happen if you divide by 0. Okay? I can show you guys sometime. I can make 1 equal 2 if I divide by 0. Weird things happen.
If you do it in a calculator, it says divided by 0 error.
Okay, so That's why vertical lines have to have a different definition about their slope. Because you guys all understand that vertical lines, two vertical lines, are going to be parallel to each other. That makes sense. But how do you say that their slopes are equal? We can't say their slopes are equal if we're talking about undefined. Okay? We need numbers to work with. We need numbers to work with in order to say that they're equal. So then we just have a separate property saying, well, if they're going to be vertical lines, then we know that they're parallel. Okay? All right. We need to know how to identify slopes just by looking at the line. Okay? Just by looking at the line, we've got to be able to identify slopes. So first off, a negative slope is always going to go down from left to right. Okay? If you graph my bank account, this is what it looks like. A negative slope.
You must do it by spending.
Okay? I've got 2 young boys.
Yeah.
They cost money. All right, so negative slope would be like line J. Well, let's take a look here. Positive slope. Positive slope would look, like if you graphed my age every year. It keeps going up. Okay. And so a positive slope rises from left to right, like line K. Now, an undefined slope, which we have already discussed, an undefined slope is a vertical line. Oops, and that's not the undefined slope I wanted. That's our y-axis. Over here, N, that's the line we're talking about. And yes, the y-axis is also vertical. But this would be line Y. No, gosh dang it, did it again. Line N. And lastly, zero slope.
Line out.
Line L. Zero slope. Now, one way to remember zero slope versus undefined slope. Zero slope, because slope is a measure of steepness, how steep something is. That is a measure of slope. And so, like the floor right now, is the floor really steep? Are we worried that we're going to slide off the floor?
No, it's a slope of 0.
No. So it has a slope of 0. The bigger the slope is, the steeper an incline is. Okay? The bigger the slope, the steeper the incline. And so, I like to think of undefined slope as being so steep it's incomprehensible. Okay?
Undefined.
It boggles the mind to think about how steep that slope is. And so that is a vertical line, has an undefined slope.
Well, mountain climbers would like that.
Okay? Yeah, it's true. That is true. Okay? So, we've identified what our different slopes look like. We now need to talk about how to calculate slope. So, coming down here, we want to find the slope of our 2 lines, line A and line C. There are 2 ways of doing this. You guys learned a slope equation in Algebra 1. And that slope equation, no, it is not y equals mx plus b. Y equals mx plus b is the equation of a line. It happens to have slope in it. It's called slope-intercept form. This one is going to be m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is our slope equation. Okay, that's our slope equation. And so we could use that slope equation on this first example to find the slope of line A. Now you kind of got to dig around on here to find out where line A is, but it is this guy right here. So there's line A. Now, you see there's 2 points on line A. There's 1 point here at 0, 2, and there's 1 point over here at 4, 6. And so, to find the slope of line A, and by the way, sometimes they're going to go through and give you a subscript A, so that we know that that's the slope of line A. Okay, that's what that means. So the slope of line A, we would plug into our slope formula. Take the y-coordinate of 1 point minus the y-coordinate of the second point. And it doesn't matter which one you call first and second point, by the way. Okay? But what matters is whatever point you started with, that's what you start with on the x's. So I started with 4, 6. So therefore, when I do my x's, I've got to start with 4 minus 0. Doesn't matter which one you call first or second, but you have to stay consistent on how you plug them in. And so I get 4 over 4, so I have a slope of 1. Okay? I could do that. There's nothing wrong with doing it that way. But I don't have to. I could, since it's graphed, simply count. Let's look at the graph more closely here. I can calculate slope between any 2 points on a line. And so now I am given a point here and a point up here. So I can go ahead and count from there. So let's count my rise. Let's start from, say, the point that I started with before. So I'm going to start up here at 4, 6. If I count my rise going to that second point, I have to go down first, right?
Yeah.
So I'm going down 1, 2, 3, 4. So that's a rise of -4. Well, now I got to count my run. Again, going to my second point. So I'm going to go 1, 2, 3, 4. I had to go to the left, and so again, that is a -4.
Depends on what thing.
It depends on your direction. That's why you have to stay consistent on how you do that. And so therefore, again, I can find the slope of line A as -4 over -4, my rise over my run,
Then 2 negatives equals positive.
which gives me, again, a +1. Okay? It doesn't matter what direction you count from, and it doesn't matter which 2 points you use. What if I use this point here and that point there? I can count up 1,
Over 1.
right 1, and so again I have a slope of 1.
You just have to use 1.
Okay? So it doesn't matter which 2 points you use. It doesn't matter from which direction you count. I think of slope as stairs. Okay? We can go upstairs and downstairs. Same thing with slope. You can count slope going up. You can count slope going down. But the steepness of the stairs is the same, right? Stairs don't change their steepness halfway through. Okay, so everybody, please calculate the slope of line B. Can everybody find line B? It's sitting right here. I'm tracing it in blue. Please calculate the slope of line B for me. Ready, set, go. Regardless on how you work this problem, if you count it on the graph or if you use the formula, we should all be getting -1 for our slope. Okay? We should all be getting -1 for our slope. You got a positive what? Okay. I'm happy you were joking. All right. So, now that we know or reminded ourselves a bit about slope, we already knew quite a bit about slope from Algebra 1. Let's go down and talk about writing equations of parallel lines. Writing equations of parallel lines. Now, again, something, and this is what you guys all wanted to tell me about slope at the beginning of class. It's called slope intercept. Slope intercept form for a line is y equals mx plus b. M is the slope. B is the y-intercept. By the way, the y-intercept is always located at the coordinates 0, b. Anytime you're given a y-intercept, or if you look at a graph and you're given the point 0, 5, you know that 5 is your b value. Okay? Because the y-intercept is always located at 0, b. All right. Well, there are multiple ways of solving this problem, but we want to write the equation of a line that is parallel to this guy and that passes through the point -1, 8. Okay? So, what we're going to do, we're going to go through and first off write information about our line. I literally write our line or my line off to the side. And I know that our line passes through the point -1, 8. What about the slope of our line? Right. We want to be parallel to the line they give us. And the line they give us has a slope of -3. How do we know that? Because it's in the slope position of y equals mx plus b. Right? So therefore, -3 must be the slope of that line. Therefore, our line has to have a slope of -3 as well. Groovy? All right. Here's how we're going to find the equation of that line. We're going to start with slope-intercept form. We're just going to write down y equals mx plus b. Next, what we want to do is plug in everything we know. We know a point. We know the slope. Here's the thing. When you're given a line, the points on the line are represented by x and y. That's why when you write the equation of a line, you don't actually plug in for x and y as your answer. Because x and y represent every single point on that line. We currently know one of those points. We currently know the point -1, 8. And so I know that when y is going to be 8, x is going to be -1. So I can plug in for x and y. I plug in for x and y. I plug in -3 for my slope for m. The only thing I don't know about this line is b, the y-intercept. But you know what? I can solve for that real quick. 8 equals 3 plus b. Subtract 3 from both sides. 5 equals b. Don't stop there. That is not the answer. We want to write the equation of the line. Y equals mx plus b. We know the m. We know the b. So plug in for those. Y equals -3 times x plus 5. Questions on this example? Kind of remember doing this from Algebra 1?
Oh, yes.
I'm hoping so. You guys probably spent quite a bit of time on it in Algebra 1. Okay? If not, make sure you're talking to me. Ask questions. Okay, that is what we're doing today. I want to see what you guys can do on your homework.